Welcome back. In this video, we are continuing on problem 1143, longest common subsequence. So, in last video, we did top down solution for this problem. So, we have a cache and we have indices of the strings. And if they are the same, if they are out of bounds, we return 0, and if not in cache, we do this part. And this is all, I'm not sure why it's not written, but time complexity. So both is O, well, let's be 1, 1, 2. And the question is, can we do better? So time-wise, actually not, but we can do something with the space. And that something with the space requires a bottom-up approach, so iterative DP solution. Okay, let's try to get that. I'll just delete everything and maybe describe the idea. So let's see on this example, we have A, B, C, and here we have A, B, D, E. Like this, so it's okay. So what's an idea? So this is actually a table, because when we do bottom-up approach, we need to think of in terms of some tables, especially where it's 2 dimensions, like here. Let's imagine that we are doing this. So this cell, I know it's a bit hard, but this cell that belongs to C and E. So this one, let's consider that to be so longest common sequence between this string on and this string on. So since this is the end, this will be 0. So we cannot match anything here. Okay, since we cannot match anything, there is 2 things we can do now. We either go to the up, or we go to the left. And what means going to the left and what means going to the up? If we go to the up, we consider C, and we consider only C, and from other string we consider more and more elements. And I'll do this row by row. So we start from the last row, and we need to check when we consider full first string and second string, what is the largest common sequence. So let's check what is the largest common sequence between also BC and E. And how can we calculate that? Well, we know it's 0, but is there any other way? What if this was, let's say, E? It wouldn't be 0 because we could match these 2. So essentially what we're trying to do, because we already did some computation, we can just match this letter and this letter. So exactly the position, because we know that this one and this one matched if they're matched, or not matched if they didn't match. So again, 0 here. So it's this one plus these two. Actually, is it? When I think about it, if both were E's, this would be 1. Okay, so it's a little caveat, but maybe we'll see the example, or let's do it like this. So this wasn't completely true what I said, because if we have this example, we will have 1 here, and if we increase the array, since for this one we already have 1 match, we cannot consider this one. So essentially, if they're matching, then we need to skip the rest of them, because this is the best we can get with 1. So essentially, anytime we get 1, we have a match, we should progress and increase both strings by 1. And if we do not have match, then we can do what we did. So let's bring here, let's have D, just for sake of it. So D and E, that's 0. Then we progress. I'll just progress in this direction and go row by row and see if we have enough information. If we use E and D and E, so if these two match, that's a 1. And from there on, it's always just 1. So we can just, for this position, we input 1, and we need to go position further, because this is the best we can do for this. We need to go diagonally here. So for E, we will just pull the same thing, because this E is matched already. So just it's 1 if it's already used. We'll see how will that translate into code. So we are in this position now. If these two match, this is the best we can do. And let's see what happens now for this one and these two. So for these one and these two, if they're matched, they do not match, but yeah, they do not match. So I would keep this again 1, because they do not match. And if they match, we can step up. So let's go here. It's again maximum of these two, so this would be 1. If we go to the C, so if I have just, so now that I have this, I don't even need to like compare anymore. I just need to compare these two, and that's it. So if they are the same, they're not, then it's maximum from here and here. Here and sorry, here. So this is 1. They're the same, no they're not, then it's again maximum between these two. These two match, no, it's maximum between these two. Then again, does these two match? They do not match, so it's maximum from here it's 0, here it's 1. Then again, these two match, no. Maximum again, these two match, no. And the last row is again same thing, 1, but here they match, so it's 1 plus, maximum it was down there. So what's the logic actually here? Did I explain this correct? So how would we solve this? Let's imagine we have 0, 0, 0, 0, 0, 0. So since we know situations that we have, so we had if they're the same, then we progress both indices by 1 and we increase by 1. How do we do that? So here, let's try to get something like CDE. CDE. So let's start from here. We'll delete on the way. So here we have E and E. They are the same. So it's diagonal 1 plus 1. Okay, this one, D and E, they are not the same. So it's either maximum from this one or this one. This is 0. A and E, they are not the same. Sorry, 1. They're not the same. So it's again maximum from this one, and this one. So 1 again, because we consider E and hold this string. Then we come to this row. We have D. D is again, D and E are not the same. So we put maximum from here and here, that's 1. D and D are same, so it's this one plus 1, so it's 2. D and A are not the same, so it's maximum from these two. But if they were same, we would again have 1 plus diagonal, so this would work. Okay, so we go to the next row. If it's this one, C and E not the same, maximum from here and here, that's 1. So CDE and E is just 1. DE and CDE is so they're not the same, so it's maximum from these two, that's 2. AD, CD, it's again the same thing, maximum 2, 2. Now here we have again 1, we have 2 here, 2 here, and last row we have 1, we have 2 here, and we have 1 plus diagonal here. Maybe it's a bit hard to follow through, but so essentially what we do, if it's the same, we consider what's diagonally and we just add 1. So whatever was here, meaning we skipped those letters because they match, and add 1 to it because we have a match. If they do not match, then we consider what did match on the right. So if one was less, and if the other had 1 less character, something like that. So let's try to call this up. I know it's not a perfect explanation, but I don't know, these bottom-up approaches are sometimes a bit hard for me. So yeah, as we saw, so we need to have all the zeros. So zeros times length of text 1, let's say, or let's have it like this. And 1 is length of text. So whatever we do is the same. So 1 plus 1. So this 4 in range and 2 plus 1. Something like this. So for I in range and 1 plus 1 in range and 2 plus 1. So what do we do if we match? But we are not going from the 0th position, we're going from the end. So it's from n1. We don't care about the last one. Or actually n1 minus 1, minus 1, minus 1. If we match, so if text 1 of I is equal text 2 of j, then our dp of I j is equal to 1 plus dpi plus 1 j plus 1. If there is no match, dp of I j is equal to max from the one on the right and one on the left. So this, but we need to do this and this. And essentially that's it. We just return dp0, 0. So looks crazy simple. I plus 1 J plus 1. What? Oh, okay. Okay. So I used N1 as inner loop, and here I'm using it as an outer loop. So I just switch up here. This should work, or no, N1 is text one, that's for sure. Let me see. So IJ. So if text 1 is here, text 2 is here. We have text 2 rows. That's true. So we have 0 times N1 plus 1. One, two, three, four, 5, and 3. 6 and 4, that's correct. And I is N1 minus 1, minus 1, minus 1. dp of ij. What? Why is this out of range? I'm not sure what's happening. So I got 4, 2. How did I got 4, 2? Okay. So this is the problem. And 2 and 1. If this part is correct, I think this is the problem, or okay. Messed it up again. So this is the problem, but this is problem. I messed up the so J is correct. This should work. Okay. So it seems okay. And as you can see, this solution is much faster. So last one was, I think, 1000 something. But time complexity is essentially the same. And it will make a lot of sense if only that was the difference, because bottom-up approach has one advantage, and that's that we can optimize space. And how do we do that? So if we take a look here, we actually just consider either dp of next row or dp of this row. So since this is the case, we don't need to store all table. We can just store previous, which is in first situation equals 0 times So whatever is first, so and 2 plus 1, I would say. So no, those are rows. Whoop, how did I go? So I went N1. I didn't do this pretty nice. So I go, this is my rows. So rows is N1, then I have to use N2. So this is previous, and we can have current. I usually do it like this. So here I place current is equal 0 times this also, and current. So current can be changed here. I think I can mess this up, but never mind. So current, okay, and I need previous when it's this. So this is previous, this is previous, this is previous. And the last step now is to put previous is equal I for I in current. Let me just return previous of 0, but let me check if I did this correct. So for I in range n1 minus 1, okay, so this should be the last row. Current is equal, okay, for j in range n2. If text I is text j, then current of, I think, j, it has to be j, is equal to 1 plus previous of j plus 1. Current of j is previous of j. Current of j plus 1. I know tie, but we for reading current. Okay, hope it's correct. Looks good. And it works, and as you can see, memory is much better. I'll just write that down. So time complexity So currently our previous is N2 always, but we can do something better, and that's this. So if length of text 1 is less than length of text 2, text 1 text 2 is equal text 2 text 1. I think this is something we can do, and now it's mean of n2 and 1, and it's always n2 mean, but let's see, should be somewhat better, not sure, but in this case we're optimizing even a bit further because it's less. So you'll see here should be min, yes, as you can see, n2 and 1, and this is n2 times n1 times n2. Okay, I hope I clarified this a bit. Yeah, I need to also run run through many examples of DPs because I'm not pretty good at it. But yeah, just work, and practice, and you'll get it. Okay, that's all I got for this one. Thank you for following, and see you in the next one.